Hi, I'm Tim. Welcome to the channel. This will be another video in my Lightburn for Newbies series. And in this one, we're going to go into the device settings menus and some of the options that are available there. So let's just get into Lightburn and get moving. We're going to be starting with a diode machine. And the way you access the device settings menu on all machines is right up here on the top, this wrench and screwdriver icon. If you hover over it, you see it says device settings. We'll bring that up. And we're in the basic settings tab, and starting in the top left corner you have this working size of your machine, and that is going to be whatever your machine size is. This diode of mine happens to be 410 millimeter by 410 millimeter. My CO2 machine is 700 millimeter by 500 millimeter. So whatever this is, that's what your actual machine size is, and that should have been set up correctly when you did the setup process. Same with this is your machine origin, not job origin, but machine origin. That's where your machine homes to and where it knows its 0 point is. And on most diode lasers, it's the left front corner. And it is with this one. But some of them are different. Some of them have left rear. I think some of the X tools are that way, and maybe a couple others. And then your CO2 lasers will typically be along the rear side. The majority of them are on the right rear, like my Omtech, but I know Thunder homes to the left rear, so their origin is there. But anyway, that needs to be set, and once these are set up, those settings should never have to change. Okay? Moving across, laser offset. If you have a red dot pointer, if you enable the pointer offset, that's the distance that the pointer is actually away from the center of your laser, off to one side and front to back. You know, it may line up perfectly on one axis or another, but you need to check your settings on that. And if you enable that feature, Lightburn will automatically, you can place it, use the pointer to align your workpiece, and then when you start the job, Lightburn will compensate for that and move the laser over that amount and actually burn it offset by that amount. Z control, if you have an autofocus machine, you'll use these settings. Mine is not, so I don't use those. And it comes out relative Z moves only. That's just on by default, and it doesn't hurt anything. Just leave it alone. Moving down here to the left, tab pulse width. What that does, I'm going to read this right from the Lightburn documentation so I don't get it wrong. It says, when using tabs, the tab pulse width allows for additional control of the tab cut power setting. Change this length to increase or decrease the width of the pulses used to simulate reduced power cuts. So when you're making your cuts, if you have tabs enabled, this will give you an extra way to adjust the amount of power under how much the tab actually cuts. I think what it does is it actually, when it comes to the tab section, it reduces the power through that section and then brings power back up again once you get past it. And this just that setting there just changes how it reacts in that tab section. All right, moving down, we have enable job checklist. This is a handy feature. If you bring that up, you can type in check focus, for example. All right, we'll do that. I'm going to close out of here for a moment. Now let's just do that and go start, and it pops up a message, check focus. If you click yes, it will just go ahead and send the job then. If you click no, it gives you a chance to go back and do it. Then you'll have to hit the start button again in order to get that. So you can add all kinds of messages in here. Check focus, make sure air is on, make sure the exhaust is running. Yeah, anything that you would find handy, you can put in a job checklist, and that pops up when you hit the start button, or the send button if you're working with a Ruida controller. You can do that. Frame continuously, that can be very helpful as well. Typically, when you send a job and tell it to frame using the frame buttons over here, it will make one circuit around and stop. And if you're trying to manually align something, that can get a little annoying because you'll hit it and you'll think you have it, then you want to go back and check it. Got to hit frame again and do that several times. Or if you have frame continuously, it's just going to keep going around it until you tell it to stop. And that way you can take the time to get things lined up nice with that. Swap XY output to laser. That, and I'll read this again because this is not something that I deal with personally, but it says, enable this setting to rotate your Lightburn workspace to match your machine's physical orientation and swap the XY output of your laser accordingly. The green dot in the dialog window indicates the location of the machine's 0 point. The location it homes to in the is the machine's physical orientation. Select the image that matches your machine's orientation and click OK. Lightburn will automatically adjust your origin and rotate your workspace and output your machine to account for the new orientation. This option is intended for machines with Y dimensions that are longer than their X dimensions. So, like if you put an extension kit on your machine and now it's a lot longer in the Y direction than what it was, if you bring up the swap XY output to laser, and see here it's showing you the different. Yeah, that's the original. So by rotating it, it's either going to be to the bottom right or the top left, depending on how you rotated your machine. So you have to look at where your machine homes to, and this is how you choose that setting. So, one thing I missed up here is CNC machine. If you're working with a CNC machine that you just have a laser module added onto, sometimes you have to enable that setting for it to work properly. And what it says here, it says enable this setting if your machine has a rear right origin and uses a negative coordinate system. So that's going to be very limited use cases on that, but I just wanted to bring it up because it is there. Standing offset adjustment, I'll get into that when I get into the CO2 laser, because I have that enabled on that. This diode laser is not connected to this machine, so I don't have any scanning offset adjustments, just only using this for design work. So, alright, so now moving over to the right side, auto home on startup. A lot of times you want to have that on, a lot of times you want to have that off. That's just whenever Lightburn connects to the laser, it's going to home the laser if that's turned on. If it's turned off, you'll have to manually home it after you turn it on, because the laser doesn't. It will typically give you an error message if you haven't homed it before starting to use it. If you have limit switches and homing enabled. So, fast Whitespace scan. There again, I'm just going to read through here. It says, this setting boosts your laser's travel speed through blank areas of an image engraving. If the speed you set here is faster than your laser's engraving speed. This can save a lot of time if you're engraving an image slowly to get a good burn, particularly if there are large blank areas in the image. So let me just give you a quick example of where that could come in handy. Let's make this much bigger. Alright, much bigger, and I'll do an offset on it. Okay, and we'll make it a fill. Whoop. I had delete on there, didn't I? I did. Okay. Alright, so now if we go like this, and we turn on traversal moves, it scans across all the way, from side to side. And it's just got a little bit of space that, you're just engraving this just a little bit and you're going way across. So if you enable that setting, what'll happen is it'll engrave at your engraving speed, then it'll zoom across till it gets to back here to the other side and slow down, do what it needs to do, turn around, do the engraving, zoom back across. So that's what that setting does for you. And here you set the speed. So like if your speed has if your laser has a maximum speed of say 9,000 millimeters per minute, you'd probably want to put 9,000 in there, and you may only be engraving at 3,000, but in those large blank areas it'll speed up to 9,000 to go across them because it doesn't need to be burning. Enable $J jogging. Here, once again, newer versions of GRBL 1.1F and later can use this custom jogging mode. Enable this setting to add a continuous jog switch to the move window. After also enabling continuous jog in the move window, you'll be able to hold an arrow key to begin jogging in a direction and release to stop cancel move. Continuous jog has several benefits over normal jogging. It doesn't affect the G-code parser state. If soft limits are enabled, jog commands that would go out of bounds are ignored without triggering an error alarm. It allows for canceling a move. So let me show you what that does. I'll enable that. Actually, that's enabled. Turn it off. Now we come to the move window. We have continuous jog turned on. And what that'll do is, instead of moving 50 millimeters or whatever you have this set for over here, as long as you're holding down the button, it's going to keep moving. If you turn continuous jog off, it's only going to go by the amount that it's there. Turn it back on. If you use the jog window here to move positions, it will actually let you run into the rails and start grinding and run out of bounds. Or if you have this turned on, it will respect your machine limits and won't allow it to go out of bounds. At least that's the way I understand it. Enable DTR signal. Certain machines require this data transfer mode. This setting controls whether Lightburn sends a data terminal ready signal to the controller to start serial communication. Many programmable hobby level controllers, including Arduino based systems, use the DTR pin to reset the controller. Lightburn usually sets this value for you, but if your G-code controller won't communicate, toggling this may help. So you may or may not need that. The Enable Laser Fire button. That's one that I like to have turned on. And laser on when framing, and we'll put that to like 0.5%. And I'll click, I'll show you over here. Now we have a fire button in the move window. What that allows you to move the laser to any position you want, particularly if you don't have the external red dot pointer and you're using you can use the laser itself for framing. So you move it where you need it to be, and you click the fire button, and it'll turn the laser on at that low power speed. At that low power, you can see it well, but it's not enough power that's going to burn anything. And then you can use that for alignment purposes. Also, that when that is enabled, whenever you click the frame button, it turns on the laser at the same time and frames it with the laser running. So you're not just having to guess where the actual laser beam is going to be hitting. You can see it if you have laser on when framing. So, enable out of bounds warning. When it's enabled, this warns you if your cut will go outside the laser bed area. Disable this if you don't have homing switches. Yeah. So it gives you a warning if your project is outside of the area. Not just in absolute coordinates. If you're off the bed, it'll do it. But if you're using user origin or something, then it will know that where it's at, it's going to go out of bounds and hit, and it'll give you a warning message. Enable G-code clustering. It's another thing that's very device specific. G-code clustering condenses the command sent to your device. For devices that support it, this reduces the bandwidth needed for communication and allows the controller's motion planner to see further ahead. For devices that don't support this feature, enabled it will result in a GRBL error. More info is available on the forum. So that's one of the things. If you need it, you need it. If you don't, you don't. So, and I can't tell you any specifics of who needs it and who doesn't. But hopefully, if you got the LBDEV file with your laser, this should be enabled if you need it. That's simple. Return to finished position. What that does is when your job is done, if you have this unchecked, when your job is done, laser stops at the end. When it's wherever it happens to be in the world, it stops. If you have this enabled, you can tell it where to go. Right now, this one's set to 0, 0. So when the job's done, it'll return to the home position. On my work machine that I actually use for this diode laser, I have it set to where it goes to the back right, because I'm inside an enclosure, and if I can open up the enclosure, I don't have to work over top of the laser. It moves the head out of the way, and I have all the room to work and everything. So you can set that to wherever you want. Air assist. This is the command that Lightburn either sends an M7 or an M8 command to turn the air assist on and off. And that is going to be specific to your device. There again, if you had the Lightburn file from your manufacturer, it should enable whichever one is correct for that, if you even have air assist on your machine. So, S value max 1000. This one is hugely important. Not the fact that it says 1000, but the fact that it has to match whatever the $30 setting is in your on your machine. So if your $30 on your firmware is 1000, this must be 1000. If it's 256, this must be 256. If it's 10,000, it must be 10,000. Those are 3 values I typically see. The majority of them on modern machines are going to be 1000. I typically see 10,000 on CNC machines that have a laser module attached to them. That's where I've seen that more often than not. And 256 is for the older 8-bit, I think it's 8-bit machines, that require GRBL M3 or something like that. So that's a just you need to make sure this matches. And let me show you how to find that information. All right, I opened up Lightburn on my other computer now, where that's actually connected to this diode laser. And the easiest way to find your $30 settings is go right there. I'll show you again. Edit, Machine Settings. And if you look right down here, maximum spindle speed $30 is 1000, which matches exactly what we have on the in the device settings. So that's one way to find it. Another way to find it is if you come into the console and you type $$ and enter, it'll print out the entire list that you can look at, and you go to $30 and it's 1000. So that's how you can see that. Let me get out of this one and back there. Okay, so that was that. Your baud rate there again, that'll be set during setup, and transfer mode buffered or asynchronous. Use whatever communication protocol works for your machine. Now in GCode, you can actually append some starting GCode or ending GCode. I've never had use for that, so I don't know anything about it other than it's there. And then additional settings. What this does is it reads your controller, what the maximum speed, your acceleration speeds and all that are at, and fills them in this table. And this information is then used with the preview window to estimate your job times. So this does not affect how your machine works at all. This is only reading the information to give it a better estimate of how long it will actually take to cut the job using your preview window. So that's all the settings that we're going to find in device settings for this diode laser. Now let's jump over to my CO2 laser. So here you see the same thing. Only difference is the difference in the size, difference in the origin point. Everything else here is still the same. Enable U-axis. Some lasers have a U-axis. Mine does not. Tab pulse width, job checklist, everything the same. Frame continuously. Overwrite files on device by default. That's a setting that if you use the send button rather than start button, and I highly recommend if you're running a CO2 laser, you use the send button instead of start. When whatever your file's named, if it's an unnamed project, it's just going to send it called Lightburn. When it sends it to your laser, if you're working on the same project and just updating it and checking, and every time you have to have that one extra confirmation to do you want to overwrite this file? File already exists. Do you want to overwrite? Overwrite by default. Then just let it go. Unless you're doing some very specific things that you want to save different versions on the laser, in which case you'll have to name them differently. That's just the only way it works, because you can't have the same name. And it's truncated to a 8 character file name is the maximum on that. So just have to deal with that. Other options over here, we have start and end delay. Delays the start of a job to allow time for exhaust fans or other accessories to start, and delay it shutting down if it wants to keep the fan. If you're The main usage for that is if your fan is controlled by the laser on and off. You want the fan to ramp up before you start burning, and you want the fan to keep running after it's done. So you'd use your delays in there. Enable laser 2 controls and offset. That's only viable if you have a 2-head laser. I do not. Increment file name on send. If your file name contains a number, enabling this will automatically advance the number with each send. Okay, yeah, like if you had star 01, next one be star 02, etc., etc., etc. Disable the start button. That you can do that to where you can only work by hitting the send button. Not a bad thing. I do use the start button on occasion, but most of the time I use the send. And yeah, that's outside the scope of this video, so I'm not going to get into that. Check bounds when framing. That's basically just where the other diode laser had out of bounds warning. This is the same thing, just labeled a little bit differently. Network timeout, 5,000 milliseconds. That has to do with your how long the control waits before giving up. And this is the IP address because I'm connected via network. So that's that. Now, I said I was going to talk about scanning offset adjustment just a little bit. What I did on my CO2 laser here is I have 3 settings. I did 100 millimeters per second, 300 millimeters per second, 500 millimeters per second. And I did make some adjustments. It's a process to go through, but you see there are values in here, and that cleaned up my engravings considerably when I did that scanning offset adjustment. Well, that's our video today on the device settings menu in Lightburn for Newbies. Go ahead and give the video a like, subscribe to my channel, stay tuned for more videos in this series, and we'll see you next time. Thanks for watching.